With this video, class 8, we are going to start the third chapter in a book, which is force and pressure. Now, although the name of the topic is force and pressure, today we are only going to discuss force, which of course you have dealt with, you've done in class 6 and 7 also, that is the junior classes, okay? So force and pressure is basically push or pull. That is, whenever we push or pull any body, an object, okay, we say we are exerting force on that body. So push or pull basically is force. Now this force or push or pull, it tends to produce movement in a body or changes the shape or size of a body. Let me discuss this point first. Changes the shape or size of the body. I have this piece of paper, okay, this piece of paper. Now what I do is I'm squeezing this piece of paper. Although I'm not showing it in the video, okay, you have to trust me. Okay, so I'm squeezing this piece of paper, and here, this piece of paper has turned into a ball. Okay, that is, both the shape and size of the body has changed. Okay, so I applied force on the piece of paper that we had, and it has turned into a ball now. Okay, so it's both its shape and size has changed. So this is what happens whenever we exert force on a body. Either the shape or size of the body changes, or the body starts there's some movement that is produced in the body. Like the body is not moving right now, we say it is at rest. Okay, I apply a push, I push the ball, okay, there is movement produced in the ball. Okay, these are the effects that force produce. All right, okay, so and why have I written this word over here, tends to produce movement? Because whenever we apply a force on a body, it's not that the body starts moving always. Okay, like for example, I have a concrete wall, okay, and I start pushing that concrete wall. Obviously the concrete wall is not going to move. All right, so but still we are applying a force there. Don't forget, we are applying a force, but the concrete wall doesn't want to move, does not want to budge from its position. Okay, so that is why we are writing this word tends over here. The force wants to make the concrete wall move, okay, but still the force is not enough to make the wall move. So therefore it wants to, but can't. Okay, so therefore we are writing this. It tends to produce, means it wants to produce. Okay, all right, so this is the definition of force that we write. Force is push or pull which tends to produce movement in a body or changes the shape or size of a body. Okay, all right. Now some examples of force that I've written over here. A football lying on the floor when kicked starts moving. Kicking a ball is like pushing the ball. Okay, so the ball starts moving, so that's an example of force. A door, when pushed or pulled, opens up or gets closed. This is also, so when the door is pushed or pulled, okay, it moves. All right, it either opens up or gets closed, so that's an example. That push or pull is an example of force. When a rubber band is stretched, its length increases. Okay, so when we stretch a rubber band, what happens is its length increases. So what are we doing? We are pulling the rubber band, so that's an example of force. A piece of paper, when squeezed, its shape and size, of course, and size changes. Okay, I have just demonstrated this very thing in the video itself. Okay, so these are some examples of forces. Okay, and don't forget the definition of force. I want you all to pause the video and write the definition and the examples. It's not that you have to copy my definition, okay, or you have to copy my examples. Okay, if you wish to, you can, of course, you're free to write your own examples. Okay, it has to be correct, but all right, then after, see, force is a physical quantity. You've studied about physical quantities in 7, in 6. Okay, what are physical quantities? Physical quantities are things that can be measured. Anything that can be measured is what is called a physical quantity. And there are so many physical quantities that you've studied about so far. Okay, mass, length, time, temperature, area, volume, density. Okay, so likewise, remember, force also is a physical quantity. There are so many other physical quantities. I've only named a few. Okay, and force, don't forget, happens to be one kind of a physical quantity. Force is a physical quantity. Force can be measured. Now the different, see, to measure any physical quantity, we need the help of a unit. Don't forget that. Okay, so force also needs some unit for it to be measured. Okay, now the different units that we use are, number one, Newton. This is the most important unit which is used to measure force, and this also happens to be the System International Unit of Force, SI unit of force. Some people also call it Standard International Unit. Okay, but actually the full form is System International Unit of Force, SI unit of force. Dyne is the CGS unit of force. What does CGS stand for? Centimeter, gram, second. Centimeter, gram, second are the units of the three most fundamental quantities, respectively, which are length, mass, and time. Remember that. Length, mass, and time are the three most basic physical quantities. Okay, also called fundamental quantities. So based on the units of these three quantities, there is a system of unit that has been defined, which is CGS system. Okay, C stands for centimeter, unit of length. G stands for gram, unit of mass. S stands for second, the unit of time. Don't forget. So the CGS unit of force is dyne. Then, in addition to these two, we still have two more physical quantities. Two more units. One is called kilogram force, denoted by a small k, small g, small f, kgf. So wherever you see this notation, this symbol, you have to understand it is kilogram force. Okay. Likewise, we have gram force. Gram force is g, small f. Okay. So this is, wherever you see this, you have to understand it's gram force. Okay. Now, let us try defining some of these units. Not all, some of these units. Like, for example, let us try defining Newton. Okay, now I cannot demonstrate this to you. Okay, you have to take my word here. You have to trust me. All right. The definition of Newton goes like this. It is the force with which the earth pulls a mass of 100 gram towards itself. Okay. So what happens is, I have this pen. Okay, I have this pen. When I let it go, what happens to the pen? It falls down. Okay, not just this pen, anything, a piece of chalk, a piece of paper, anything, an eraser, a stone, whatever. We ourselves, okay, if say for example, I want to fly and I jump out of the window, say for example, obviously I won't be able to fly. Okay, of course, please don't try this at home or anywhere. Okay, so I want to fly, I jump out of the window, I'm going to land, I'm going to fall down and land on the floor, on the ground. Okay, it's a very bad example I think I'm giving. Okay, but remember, whenever we let anything go, like this pen, okay, it falls down like this. Now why does it fall down? It falls down because the earth is pulling anything towards itself. The earth is pulling us also right now at this very moment towards itself, towards its center, to be more specific. Okay, so I let this pen go. When I let it go, it falls down like this because the earth is pulling anything towards its center. All right, so the force with which the earth pulls a mass of 100 gram towards itself, okay, is what is called a Newton. You must have seen a weight of 100 grams, okay, in different shops. So a weight of 100 grams, when you take a weight of 100 grams, you're holding a weight of 100 grams on the palm, say for example. Okay, a weight of 100 grams on the palm, on your palm. Okay, the force that you feel on your, palm, you feel a certain weight on your palm. Okay, now weight basically is force. Weight is a force, don't forget. All right, so the force that you feel on your palm when you place a weight of 100 gram, okay, on your palm, of course, is what is a force of 1 Newton. So it is the force with which the earth pulls a mass of 100 gram towards itself. So when you let that 100 gram weight fall down, it bangs the floor with a certain force. All right. So the force with which the earth pulls a mass of 100 gram is what is called Newton. Remember that. Likewise, kilogram force. What is kilogram force? The definition, it's there in the name itself. Remember, kilogram force. Kilogram means 1 kilogram. So the force, F is force. What kind of a force? Force with which the earth pulls a body. The force with which the earth pulls a mass of 1 kilogram towards itself is what is called 1 kgf. I repeat, the force with which the earth pulls a mass of 1 kilogram towards itself is what is called 1 kilogram force. Okay, now to experience this 1 kg force, 1 kg of force, what you do is you must have seen a weight of 1 kilogram. So you take a weight of 1 kilogram on your palm. So the force that your hand experiences, okay, is what is equal to a force of 1 kilogram force. Okay, that would be the force that your palm feels when you place a mass of 1 kilogram in your hand, okay, is what is 1 kgf. Likewise, gram force now. The force with which the earth pulls a body of mass 1 gram towards itself. Of course, we haven't seen a mass of 1 gram. It's very small. Okay, so the force with which the earth pulls a body of mass 1 gram, which is a very small mass, okay, is what is called gram force. All right, okay, so this much for this video. I'll be making another video where we are going to discuss thrust. Okay, so till then, stay safe, take care, class 8. Any problems you have, any difficulty you have in understanding the things that we will be doing, okay, you can always let me know. Okay, you can write in the comment section of this video itself, or you can write in the WhatsApp group itself. Okay, all right, thank you.